Good morning, everyone. This is Shiva from Soundbus Irrigation Design Services. Today, we are going to discuss about the topic smart irrigation. As we know that July is the month for smart irrigation of Irrigation Association, so we chose this topic to discuss some of the concepts behind the smart irrigation. So, hope you will enjoy this. If you have any doubts, kindly ask me anytime. So, let's get back into the topic first. So, what is smart irrigation and how they differ from conventional irrigation system? We know that we are using irrigation system and we are scheduling them according to the crop water requirement. We know that crop water requirement is higher in summer season and lower in winter season. So, but we are scheduling the irrigation according to the previous year weather data, but we cannot measure the uh, upcoming years weather data or today's weather data on live basis. But in smart irrigation, we are just measuring the evapotranspiration on live basis, which will be very effective to conserve the water. So this is the major difference between smart irrigation and uh, conventional irrigation system. So after the smart irrigation entry, we are using the solar sink, we are using the rain sensor to maintain to conserve the water. So there are two factors which is majorly used to manage the smart irrigation management. One is evapotranspiration and another one is soil moisture content. Today we are going to discuss about evapotranspiration, and in the upcoming parts we will also discuss about the soil moisture content. So first, which factors affect the evapotranspiration majorly? First, before that, let me discuss about you what is evapotranspiration first. What is evapotranspiration? Evapotranspiration is equal to transpiration plus evaporation. Evaporation is the evaporation of water from the soil surfaces. Transpiration is the loss of water from the leaf surfaces. So both these terms combine to form the evapotranspiration. We cannot measure separate the evapotranspiration and we cannot separate the transpiration and evaporation in the field condition because both soils and uh, leaves are present inside the field. We don't have we cannot separate the evaporation and transpiration in the field, so that we are combined this term and we call this term as evapotranspiration. And which factors affects this evapotranspiration? So there are majorly five factors which affects the evapotranspiration rate. One is sunlight radiation, air temperature, relative humidity, wind speed, and soil water. And we will discuss this about this one by one in the upcoming slide. We know that this is sunlight radiation. uh, Sunlight radiation is comes from sunlight, and it only 51% of the sunlight radiation reaches the surface. The rest of the 49% has got deflected into the atmosphere. See, look at here. Some 6% of radiation is deflected by the atmosphere, 20% deflected from the clouds, 4% is deflected from the uh, surface, earth surface, 16% also absorbed by the surface, some is absorbed by the clouds. So only 41% reaches the surfaces. So as we know that in summer solar radiation is very higher, so the transpiration rate is also very higher in the leaves. But in winter we don't have that much sunlight which will not heat the surfaces, so the evapotranspiration rate is very lower in this surface. We are usually measuring this sunlight radiation in watts per square meter. And the next one is wind speed. We know that we don't feel comfortable when there is no wind. We feel sweaty in that no wind condition. Similarly, plants also feel form sweaty uh, above the plant leaves, surface of the plant leaves. So if there is no wind, transpirations will be suppressed by the layer above the leaf surface. But if the wind speed is very higher, the layer there will be no layer on the leaves. Only the many water can be get out from the leaves. So the transpiration rate is very higher in if the wind speed is very higher. As you see this, you know that wind velocity increases, the transpiration rate also get increases. So from this curve you can see that wind velocity is also a major factor behind the transpiration rate. Next one is air temperature. Transpire more rapidly at higher temperatures. We know that if there is more temperature, there will be more evaporation. So you see this, look at this example. 80 at 80 degrees Fahrenheit, a leaf may transpire 3 times as fast as it does at 68 degree Fahrenheit. Water is evaporated through the stomata of the leaves. So if the temperature is very higher, then the evaporation from the stomata is very also higher. So automatically evapotranspiration rate will be very higher. So we need to irrigate more water at the summertime. So and then another factor is relative humidity. Humidity, if the humidity is very very higher, then the rate of transpiration is also higher in that condition. Sorry, if the humidity is very higher, then the rate of transpiration will get lower. So if the humidity is lower, then the rate of transpiration is also higher. From this graph, you can see this. At lower humidity, transpiration rate is also very higher. At the higher humidity, transpiration rate gets lower. And if you have any doubt about humidity and what is humidity, then just ask me. I will make a video about relative humidity in separate part. And another factor is soil water. A plant cannot continue to transpire rapidly if the water loss is not made up with a replacement for the soil. So if we don't irrigate the water for a long time, then the plant will start to close the stomata, because there will be water. There will be no water in the leaf. So plants also start to close their stomata, and it will automatically reduce the evapotranspiration rate. So soil water availability is also the major factor behind the evapotranspiration rate. And how to calculate this evapotranspiration rate? This is very very challenging factor for the irrigation experts. So not only irrigation experts, everyone, environmental engineers, everyone is very eagerly to find this evapotranspiration directly, but it is very very difficult. There is no way to find this evapotranspiration method very easily. As we know that these factors determines the evapotranspiration rate. So if these factors changes, then the evapotranspiration rate will also changes. First, this ETO means that potential evapotranspiration. uh, so we are first measuring the transpiration rate for the grass. But we don't only have a grass, we also have different types of plants like trees, shrubs, and mulches. So we need to multiply the Kc factor according to the plant types, so that we will get the evapotranspiration rate for the different plants. Kc factor is available for different plants. If you multiply the Kc factor with this evapotranspiration, with this reference evapotranspiration rate, then we will get the evapotranspiration rates for each plant. And yeah, this is the Penman Monti equation, which is widely accepted method to calculate the evapotranspiration rate. As we know, you see this, we need this much data to calculate the evapotranspiration. That's why I said you that calculating evapotranspiration is very very challenging method in today's world. We need radiation, we need heat storage, we need air density, we need specific heat of air, aerodynamic density. This much data we need just to calculate this evapotranspiration. So it is very very difficult for the many experts to calculate it. So we have this only method to calculate evapotranspiration method. Apart from that, we don't have any other method. So this is widely accepted method. So because of that, we are using uh, these much values, right? So I will discuss about this, how to calculate this, to how to calculate the evapotranspiration with the help of the crop water requirement software, which is developed by the Food and Agriculture Organization. And and if you have any doubt regarding regarding the points we have discussed before, you can ask me anytime. And the next one is, this is the sample smart irrigation process, how they are uh, using these weather data. You know that every area has a weather station. So Delhi has a separate weather station, Chennai has a separate weather station, Noida has a separate weather station. As like that, in every corner of the world, we have different weather station according to the area. So it measures the weather data for each areas, and it will send this data to the satellite, and we will get this data from those satellite anywhere from the world. So and then they will use this uh, radiation value, air temperature, everything. We will use we use those value to calculate the evapotranspiration, and then it will send those signals to the um, wireless network, and then those values will be sent to the controllers, and then controllers will automatically adjust according to the weather. So we cannot achieve this, we cannot adjust the watering schedule according to the weather in conventional irrigation system. Only in smart irrigation we can achieve this. So this is why smart irrigation is getting popular nowadays. And so it's better to use smart irrigation method to conserve a lot of water. It will automatically save you many water cost. So as of now, thank you for joining today. And if you have any doubts regarding this, you can contact me anytime. And yeah, thank you. We will join again tomorrow. Bye bye.